Hi everyone, what's up? Welcome back to my tutorial channel. It's Daniel here, and today I'm going to show you how to compare the means for pair symbols. So in order to compare the means for pair symbols, we are going to use t-test. So in the lesson today, I'm going to first show you how to use t-test for pair symbols, then how to perform the critical value method, the p-value method, and finally how to construct the conference symbols for the difference of the means of two pair symbols. So let's look at this situation. The Toyota car engine improved the car's mileage. A sample of 8 automobiles were drawn to determine their mileage in miles per gallon. Then each car was given a turn-up and run again to measure the mileage a second time. So this is the data set. We have 8 cars, we have 8 automobiles, and we have the mileage before turn-up and after turn-ups. You see that? This is an example of pair symbols because we use the same 8 cars for 2 treatments. One is before turn-up and the other one after turn-up. And then we compare the mileage before and after. So here for this pair symbols, if we take the difference by taking each number in the after turn-up, subtract the corresponding number in the before turn-up, we have a new symbol of 8 numbers. We have a new symbol of 8 numbers. So this is a symbol of the differences. You see that? So instead of testing mu1 and mu2, we basically can run the one symbol test using the different symbols. That is the idea of t-test for pair symbols. So now look at some notation. Here we use mu d is equal to mu1 subtract mu2. It is the population mean difference for the matched pairs. D bar is x1 bar subtract x2 bar is the symbol mean of the differences between the values. At D is a symbol mean of the differences between the values in the matched pairs. And the assumption for this test is we have 2 pair symbols that are random. Number 2, either the symbol size is large or the differences between the matched pairs come to a population that is approximately normal. And before we do the test, we need to state the null and the alternate hypothesis. Here for the left tail, mu1 is equal to mu2 is the null hypothesis, and mu1 is less than mu2. But if we use the different symbols, we can make the equal statements. Mu1 is equal to mu2. It is equivalent to mu d is equal to 0. That means there is no difference. If mu1 is less than mu2, we have mu d is less than 0. So from the 2 symbols, we have modified the problem to become the one symbol test. You see that? And we can use t-test for the symbol of the differences. Similar for right-tailed, the null hypothesis is mu d is equal to 0, and the alternate is mu1, mu d is positive. The two-tailed, mu d is equal to 0 is the hypothesis, the null hypothesis, and mu1 is not equal to mu2, which is equivalent to mu d is not equal to 0. This is the alternate. Alright, so now let's look at the critical value method. Now we are going to focus on the symbols of the differences and ignore the symbol of before and after. So the test status here is the z-score of the symbol mean of the symbol of differences. T is equal to d bar, subtract mu d over hd over 12a. assuming that the null hypothesis mu d is equal to 0 is true. And the critical value method is based on the idea that we should reject the null hypothesis if the value of the test status is unusual, when we assume that the null hypothesis is true. In this method, we choose a critical value, which forms a boundary between the values that are considered unusual and the values that are not. The region that contains the unusual value is called the critical region. If the value of the test status is in the critical region, we reject the null hypothesis. If we reject the null hypothesis after choosing a significant level, alpha, we say that the result is statistically significant at alpha level. We also say that the null hypothesis is rejected at alpha level. And now let's look at these three pictures. First, for the right tail, the critical value should be a negative number that separates alpha area to the left and 1 minus alpha to the right. So if the test status falls into this shaded area, we reject the null hypothesis. That means if t is less than or equal to minus t alpha, we reject the null hypothesis. For the right tail, the critical value should be a positive number, and the critical region is the area to the right of it. Here, the critical value separates 1 minus alpha area to the left and alpha area to the right. So the critical value here is t alpha. The critical values are t alpha half and minus t alpha half for the two tails, and the critical regions are the two tails. Alright, so now let's perform the critical value method. The first step, we have to state the null and the alternate hypothesis. Step 2, we choose a level of significance alpha and find the critical values. Step 3, we compute the test status. Step 4, we determine whether to reject this or not. For the left tail, we reject the null hypothesis if t is less than or equal to minus t alpha. For the right tail, we reject the null hypothesis if t is greater or equal to t alpha. And for the two tail, we reject this if t is greater or equal to t alpha half or t is less than or equal to minus t alpha half. Simply, if the test status falls into the rejection region, the critical region, we reject the null hypothesis. And step 5, we state the conclusion. So that was the critical value method. Now let's look at the p-value method. The p-value method to measure just how strong the evidence against the null hypothesis is. We compute a quantity called the p-value. The p-value is the probability that a number drawn from the distribution of the sample mean would be as extreme as or more extreme than our observed value of the sample mean. The more extreme the value, the stronger is the evidence against the null hypothesis. The p-value is the probability, assuming that the null hypothesis is true, of observing a value for the test status that is as extreme as or more extreme than the value actually observed. The smaller the p-value, the stronger the evidence against the null hypothesis. For the left tail, the p-value is the area to the left of the test status under the curve. For the right tail, the p-value is the area to the right of t. And for the two tails, the p-value is the area of the two tails, the sum of the areas in the two tails. And to perform the p-value, the first step, we have to state the null and the alternate hypothesis. Step 2, we have to choose a significance level alpha. Step 3, compute a test status. Step 4, compute the p-value, and then we reject x0 if p-value is less than alpha. Now let's learn how to perform a t-test for Pearson board through some examples. For a sample of 9 automobiles, the mileage in 1,000 s of miles at which the original front brake pads was worn to 10% of their original thickness was measured, as was the mileage at which the original rear brake pads were worn to 10% of their original thickness. The results are given below. The differences in the last slide of the table are rear subtract front. Can you conclude that the mean time for the rear brake pads to wear out is longer than the mean time of the front pads? Use alpha is equal to 0.05. So here this is the data set. We see that the first line is the time for the rear brake pads to wear out, and the second one is for the front brake pads, and we have the different symbols here. Basically we take the rear subtract the front. So if we want to test whether the mean time for the rear brake pads to wear out is longer than the mean time for the front pads, we basically test in the population mean of the difference is positive for the alternate hypothesis, whether it's positive. So here, let's say the null hypothesis here is mu d is equal to 0, and the alternate is mu d is positive. And from this symbol, we can find some statistics. We have the symbol means d bar is 10.4778. The symbol standard deviation is 0.5215, and the symbol size here is 9. So now the problem is easy. It's just like running a t-test. Alright, so this is the summary of the problems. Using the formula of the test statistics, t is equal to d bar subtract mu d over sd over square of n. Here mu d is assumed to be 0. So the test statistics t is equal to 60.2768. And the critical value methods, the critical value should be t.058. Here the degrees of freedom is 8. It's just 9 subtract 1. This is the right tail test, so the critical value should be positive. That's why we have t.05, because we want to have 0.05 area to the right and 0.95 area to the left. So the critical value is 1.86. The critical region is the area to the right of the critical value, so it should be 1.86 to positive infinity. And the test statistic here, t is 60.2768, which is greater than 1.86, so we strongly reject the null hypothesis. And similar, the p-value method, the p-value here is the area to the right of the test statistics because it's right-tailed, and it should be 3.188 to e to the negative 12 by scientific notation. This number is super small, it's less than alpha, so we strongly reject the null hypothesis. And our conclusion is there is sufficient evidence to conclude the mean time for the rear brake pads to wear out is longer than the mean time for the front pads. The last thing of today is how to construct the confidence intervals for the difference mean of pair samples. So just using the formula, the point estimate plus or minus the margin of error. And the margin of error is the products of the critical value and the standard error. The point estimate here is d bar. The critical value here is t alpha half n minus 1, because we want to have 1 minus alpha area in the middle. So we have alpha half is the area of its tail, one from the left and one from the right. So the critical value should be t alpha half n minus 1. N minus 1 here is degrees of freedom. The standard error here is the standard deviation of the difference symbol over square root of the symbol sign. So we have the confidence interval. The lower bound is d bar subtract t alpha half n minus 1 times d over square of n, and the upper bound is d bar plus t alpha half n minus 1 times sd over square of n. So that's how we find the confidence intervals for the difference means of pair symbols. Alright, so that's all for today. Thanks so much for watching my video. See you guys on the next video. Bye bye.